Here's example 5. It says sketch the graph of f of x equals 3 cosine 2x plus pi halves. And they want us to do that over the interval from 0 to 2 pi with closed brackets. So once again, this interval notation just means 0 is less than or equal to, since they're closed, x is less than or equal to 2 pi. Okay, so what I like to do, I like to just start with the parent function. So in this case it's cosine, and cosine has a period of 2 pi, halfway is pi, has a max of 1 and a minimum of -1. So you'll definitely want to memorize that. Now, let's take care of this 2. So essentially we're going to graph cosine of 2x first. And so to do that, we're going to look at the period, divide it by that number, and so our new period is pi. And so we'll need to draw this function essentially 2 times. I have a hard time drawing this, but right here we want to draw an entire cosine function. It's going to look roughly like that. Technically, this and this are supposed to line up, so it's a little bit off. And then once again, this will. So anyway, we made it occur twice as often. We increased the frequency by 2. Now, the next thing we're going to tackle, we're going to take care of this plus pi over 2. And that works counterintuitively, so it's going to shift it to the left by 2. Let's see. So when we do that, we're going to end up basically, so we're just going like this. Something kind of like that. Not exactly though. So I'm really bad at drawing, but we shifted it left too when we did that. I'm gonna graph these and just show them to you because, like I said, my drawing is really bad. And then we're gonna take this 3, which just stretches this up 3. So now if it was the yellow one, it would be like this. Whoops, go all the way down here too. Okay, now as you see, that's really messy, hard to read. Another way you can approach this, and then I'll graph it eventually, like I said. So just start with your parent function. Now probably on that first one where you compress it, this white one that's drawn, you probably want to actually do it the way that I did it before. And I drew sine instead of cosine, so let me fix that. Okay, so here's 2 pi, because we do need to draw it from 0 to 2 pi. Now, from this point on, so this is pi halves, this is 3 pi halves, this is 0, this is like 1 on the y-axis, -1, 0 on the x. Okay, from here on out, when we're shifting it left, we're just going to subtract pi halves from each of these pieces. Okay. and so we can like draw it a little bit further to make sure we get to the 2 pi. So we just kind of draw it like that, and we know this would be another, let's see, on the original it would be 2 pi plus pi halves, which is 4 pi halves, so 5 pi halves. Okay. And so when we're fixing this, the 0 becomes negative pi halves. These go away, become 0. These become pi halves. These become pi. These become 3 pi halves. And then this is our new 2 pi, because we're just subtracting pi halves from that. Okay, so this is our new, that's new. And then the only thing we need to do is stretch by a factor of 3. I think it's just easier to change these to 3. And now we have it. It looks a little bit nicer, just a little bit. Just to be clear with like what we were doing though. Let's see if I have Desmos. Yes, I do, right here. So this is the previous problem. Okay, so we're gonna look at this just as cosine x first. And then we wanted to, here I'll even get this in the frame. So we first took care of the 2, so that was like cosine of 2x. And see how it's just more frequent now? Even to make this kind of, 2 pi is close to 6, so we'll just show it like this. Okay, and then we're going to do cosine of, let's see, of 2, then x plus pi halves. And to get pi on Desmos, I just do pi. Okay, now we're looking at the black one. I guess showing you guys the labels would be nice. Okay, so we got this black one. So once again, here's cosine. Then we did cosine 2x. And now we shifted to the left. So if we just look at the purple and the black, they're identical. It's just they've been shifted. Okay, I'll copy this. And then all we do is add that 3 out in front, and we got our new thing. So notice, if we just compare the black and the red hit the same places on the x-axis, but the red one is 3 times as tall and goes 3 times lower. Okay? Alright, go back here. Now we're going to do example 5, which I think is the last one. Nope, there's a 6. Okay, so, oh no, that was example 5. So this is the last one, it's example 6. Okay, so example 6, it says suppose we have cosine theta is equal to 2/5. Calculate tan theta in the following 2 cases. So if we are between, so case A and case B. So if we're in between this, which is the first quadrant, or if we are pi and 2 pi. Okay, which is going to be the 3rd and 4th quadrant. Okay, So what we're going to use the Pythagorean identity, which is sine squared theta plus cosine squared theta is equal to 1, which I like to think of just y squared plus x squared equals 1, since sine is y and cosine is x. So I'm thinking of this as an x value, and I'll think of tangent as y over x. So I just plug this in, so I get y squared plus 2/5 squared equals 1. Square the top and the bottom. Subtract this over. I'm going to think of the 1 as 25 over 25. 25 minus 4 is going to give us a 21. And then to solve for y, I square root. I get a plus or minus when I introduce a square root. Square root at the top, I still have square root of 21. Bottom becomes 5. Now I need to check which quadrant I'm in. So in this quadrant, quadrant 1, y values are always positive, and so I only choose that. So my sine value, I guess we're going to tangent, so my y value is square root of 21 over 5. I drop the negative in that case. Now to figure out my tangent value, I take this, and I take this, and I plug it in. So I get square root of 21 over 5 over 2 over 5. When you have like these fractions with fractions in them, if the denominators are the same, you can just cancel them, and so we get square root of 21 over 2. So that takes care of the first case. Now, if we're in this situation, if we're in the third and fourth quadrant, then our y has to be negative. And so the only thing that's going to change is that instead of dropping the negative here, I'm going to drop the positive. So now I'm going to think of my y as being this. And this time I'll take this y and the same x, plug it into here. So I get negative square root of 21 over 5 over 2 over 5. Once again, those denominators cancel. I get negative 21 under a square root over 2. And that's my case B answer. If you need additional help, please come to Math Lab. Until then, calculator.